Okay, so you're on Desmos.com. Desmos is just basically a free online graphing calculator, okay? But it doesn't look like your graphing calculator that you might have learned to use like the 83 or 84. So there's a couple things we have to know about how to enter stuff specifically, okay? So just go ahead and click the Start Graphing. And it just brings you to this blank thing. You basically can enter left side, and it'll graph it for you on the right side. How many of you guys have used Desmos for something before? Awesome. Okay. So we want to use it for a really specific thing. You know how we've been like measuring your creature every day, but so far in our project, we haven't used any of that like daily information. So the main thing we were doing in your project in parts 1 through 3 is we were understanding our initial thoughts when we read the package. We were trying to understand some deeper concepts of math behind it. And then we were trying to analyze, like I have these before and after things from day 1 or day 0 to day 3. Did the manufacturer lie or not? And we were just comparing those. So then this is kind of like a little side project with the creature. As it grew each day, did it grow in a specific pattern? That's what we're kind of looking at. So in Algebra 2, you guys studied all types of not creatures. You guys didn't study any creatures, right? You guys studied all types of functions, okay? And they all had different shapes. And we want to see if like our daily creature growth kind of follows one of those shapes. So this is going to serve two purposes for us. Data analysis, which you did a lot of in Algebra 2, and kind of like a reminder of all those different types of graphs that we did. But I have a cheat sheet for you guys with like the equations and the shapes and all of that kind of stuff, okay? So what I'm going to do is I'm going to go through an example that is none of your creature data. It's like a person's creature data from last year and show you how I would put this in up here. He was in my first period. He was in my first period. Let's see. Okay. All right. So we're going to go ahead, and what we want to see in Desmos is how to put in data and run regression. It's different than just typing in equations and having it graph for us. So the first thing that you want to do, person with the computer, follow what I'm doing right now. And then the other person, can you go ahead and get out your sheet of data that has like day 0 through day 10 with your measurements on it? Okay. Okay, so those of you that have Desmos up on the computer, first thing, if you don't want this to disappear every time you put away the Chromebook or go off the internet, you want a Desmos account because you just want whatever you did to be there all the time for you to pull back up. So the first thing you want to do is sign in or create an account. If you created an account in the past, you can sign in, and then you can sign in with Google. If you did not create an account in the past, like you just used it to go on online and graph stuff real quick, or you were doing like an activity through your teachers, like whatever, if you've never created an account, then you have to actually create an account. So decide right now, are you signing in or are you creating an account, and do so. When you've accomplished this task, you'll know that you did so because of this. My name is up here in the corner. So I'm now not just like a random user on the website that anyone can go to. It's now being logged like in my account. So as long as I save it and name it, I can return to it. So go ahead and make a decision right now. I'm just going to walk around and make sure everybody has. All right. So super awesome that your teachers have made you use Desmos before, because that makes my life a little bit easier. Now, the next thing we're going to do is look in the left-hand corner. It just says untitled graph right now. If I want to keep what I'm about to do as anything important, I want to have a name with it that I can go back into my files later and find easily. If you guys look, if I click my little menu over here, I have a bunch of stuff. Okay? I don't know if some of it's named well, some of it is, some of it's not, okay? And so if it was named well, I could find what I'm looking for, and if not, then not. So again, that was from this menu button right here. But I can just go up to the untitled, and I can just click it to rename it. So I'm going to name this graph Creature Growth Data. You can name it whatever you want. You just have to be able to find it and know that it was for your creature. And notice it says saved up in the center, so I'm good. So now you guys have to know a couple of things. Number one, you have to know how to type in data instead of just an equation. So Desmos is pretty user-friendly. The plus sign up here lets you add stuff, and it gives you options. Do you want to add an expression, like something to graph, a note where you can type stuff, folder, which we'll be using next unit, image, which we'll be using next unit, or a table. That's what we're using right now. So I'm going to click table, and it's going to make a data table. Your day number and all the lengths associated with it belong in one data table. If I want Desmos to find a function that fits the data, it all needs to be in one table together. A lot of you guys thought you were jumping ahead and you went to Desmos and plotted the points, but you plotted all the points on separate lines. Desmos can't find a function for that data. It has to be in one table together. Okay? So I'm going to go ahead. I'm going to use the data that I have from a previous project, and you guys are going to use your data. So our days should match. If you didn't get a measurement for a day, don't make one up and don't just put zeros in that spot. You don't include that data point if you don't have one. I have on mine a day 0, 1, 2, 3. Then our weekend was 4 and 5, right? And then we did 6, 7, 8, 9, and 10. And so then I'm going to fill in the Y column all the lengths that went with those days. So you and your partner work on making sure the data is correct. Partner, you can be reading the person the data or double checking as they're typing in that the data is correct. So I'm just going to highlight a couple of things on Desmos for you guys. I saw a lot of you guys using the zoom in and out and zoom out features to find your data. That's totally fine. You can also just move the graph where you want and stuff like that. Just a small reminder, depending on if you've used this feature in Desmos or not, you can set the window like you would scale your own graph. Like let's say I was making the scatter plot by hand of this data. I would know that I want my X's to basically emphasize like the spots from 0 to 10. And my Y's, the smallest is 8.2 and the biggest is 21.1. So I would want that span on my Y-axis. If I'm smart enough to know that, then I can figure that out on the scale on here. So this little wrench right here up in Desmos is where you can set specific numbers for the window if the zooming in and zooming out is not like what you want to do right now. So notice it says X-axis. What do you want it to go from? Well, I don't really need to see the negatives, but I'll put -1 so I can like see the X-axis. And then I need to see all the way to 10, so I want to see a little bit past that, so maybe I'll put like 12. And then I could even, not 112, 12. And then I could even put what I wanted to count by, but I'm fine with how Desmos did it here. And then for my Y-axis, again, I don't really need to see anything underneath 0. Maybe I'll put -1 so I can see, okay? And then for the maximum, my graph went up to 21.1, so maybe I'll put like 23 or something like that. And so there's my data, okay? So now what we need to do is we're trying to establish if we think there's any function that we've learned about whose shape basically fits this data. So I want you guys to take a minute at your table groups and looking at my data. Do you remember any functions from Algebra 2 that you think have parts or all of them that might follow a shape like this? So take a couple minutes. Okay, as you guys are looking to decide which function you think fits. So this cheat sheet is like a review from Algebra 2, right? It says, here's 7 different functions that you studied in Algebra 2. Here's what the basic parent function looked like. So remember, the parent function is just the most basic form of it, nothing being multiplied, added, or subtracted. If it's a square root, it's just a square root. Cube root, okay. Logs need a base, so we'll work on that. Same with exponentials. You have your cubic, your quadratic, and your linear, okay? So you guys looked at my data, and what do you think that it behaved somewhat like? So I'll go back to my data. There's my data. So we think it looks like a log function. So if that's what I think, then I can try that. If I look at this paper again, it could also possibly be maybe a square root, maybe part of a cube root. Okay, it tends to have that flat part. There's a couple different options there. So your cheat sheet is more than just shape and name a function. It's to help you with that to review Algebra 2, but it's also to help you with Desmos notation. When you guys want to run regression, you don't just type in your own cubic equation. So if I wanted to guess numbers, I could type a cubic like this to Desmos, and I could try and change those numbers till it fits. That is not what we are doing. Desmos can find the best square root or the best cube root or the best possible logarithmic function that can fit my curve by itself. But I have to tell it that I want it to do that. So I have to be able to tell Desmos, hey, I put in data. I think it's a log, so I'm going to type this like log equation thing in here, but you come up with the numbers that should be in there that are the best fit. Okay? So let's say I think it's a log. Okay? I gave you guys below the general equation the way that we would type it in to Desmos. We're just going to specify a base. Okay? So what I'm going to type into Desmos is this. I'm not going to type y equals. I'm going to type y1. Why the heck y1? Because the table that I made in Desmos, those points were called x1 and y1, and Desmos doesn't know to go use that table if I don't use that notation here. Okay? If your table didn't say x1, y1, if you made a table, you didn't like it, you made another one and started and deleted the other one, yours might say x2 and y2 at the top. So please adjust accordingly, right? This base could change. We're just limiting ourselves right now instead of exploring that option to just a base of 2. But Desmos can pick all of these other numbers that should go in here. So let's say that I want to try that log function as something that fits my data points. So I go back to my graph, and I'm going to type in here, but remember, I want Desmos to find the numbers that should go into the equation. I just know I want it to look at a log equation. So I'm going to type y1. It automatically put the 1 in the subscript. I didn't do anything. I don't type equals. I do the little like tilde thing. That tells Desmos I want it to look at my data. This is on your cheat sheet. You just have to type it just like it looks there. Then I type A, and then I typed log because I think it's a log function. Log base 2. Nope, that didn't work. So Desmos has this keyboard right here. Okay, if you need something that wasn't there, I tried typing 2 and it didn't make a subscript for my log. If I go into functions right here, miscellaneous. There's a log with a base. So I'm going to choose that instead of how I was typing it. I'm going to erase the old one I was typing. And this one has little boxes for me to fill in. So we said we're going to do a base of 2. And then inside the parentheses, if I look on my cheat sheet, it says type x1. Again, it's subscript automatically, minus h. Okay, finish my parentheses, and then plus k. So here's what it's done for me. It's drawn the best log. I had to decide log, and I had to know the notation to type it in. But it just decided if this is logarithmic, here is the best possible log function to fit that. And then here's the information about it. So your project asks you to write the equation. Do not write this. This is not the equation. This was Desmos speak for go find me a good equation, right? My equation should say y equals, and then instead of writing a, I should write 3.108, whatever, log base 2 of x minus, instead of writing h, I should go write negative 0.455033, close, plus, and instead of writing k, I should write, so do you guys understand this is not the answer? You have to write the equation, not in Desmos speak, okay? And then does anybody remember what the r squared value does for us? What is the r squared telling us? What is the purpose of that number? R squared equals 0.9372. Do you guys remember with data? So when you guys fit a curve to your data, we want a measure of how well that fits our data, because we can tell it to fit anything. I could say, Desmos, make a line. Okay, as a matter of fact, I'm going to do that real quick so you guys can see the difference. Okay, let's say I thought it behaved like a line. Okay, if you look on your cheat sheet, there's several ways we can type this in. I'm just going to type it in like this. Oh, do you see what I did wrong? I do. Okay, there's a line if I thought a line fit my data. So you can try several things. I could try a square root, a cube root, a log. How do I decide which one's better? Well, first of all, which one looks better with my data? The line or the log function? The log function. Secondly, look at the r squared value. So r squared is like rating a gymnast. You know how gymnasts do their little thing and then the judges judge them on like a scale from 0 to 10 on like how well they performed their routine to what it said it was going to be? Okay. This is like a rating of a function, but on a scale from 0 to 1. On a scale from 0 to 1, this curve does like this good of a job describing your data. So 0.9372, is that pretty good? Sure. 0.7655, not so much. So I have two things telling me that that's not a good data model for my data. One, this number is not very good. And number two, the line does not look like it is following the data points. That is important, okay? Now, let's say that I did like a cube root. Let's say I thought maybe this is part of a cube root, so line was a bad choice. I'm going to try a cube root. There's notes on your cheat sheet about where to get the cube root if you're not sure. So if you didn't follow what I just did, it's on there, but you have to read. Figure it out. All right, there's a cube root. So a cube root wasn't my initial thought. The whole thing doesn't look like a cube root because it doesn't really go the other way. But from there forward, does a cube root seem to fit the data pretty well? Visually, it's very appealing, right? And if you felt like they were tied visually, like they both looked good, again, look at the R-squared value. This was a pretty good R-squared value, 0.9372. But what's this one? 0.9979, right? But I don't look at this alone. It has to also match with my eyes and make sense for the data. So you guys in part 4 are putting in your data. Like one thing is a screenshot from Desmos with your data in there. Then you're typing the equation. Don't just say it's in there. Retype it in the correct format. You're going to tell me the R-squared value. You're going to tell me which equation you chose and why. And the why should be what we were just talking about. I'm visually looking at what fits my data best. And I have this evidence, this rating of how well it fits my data. So those two things combined together are telling me this might be a good choice. And then once you have an equation, there are questions about that. Like, in this many more days, how much would you expect your creature to grow? Do you feel there are limitations to your model? And things like that for you to analyze, okay? Does everybody feel like they can put their data in Desmos? You already have a good jump on it right here. That you can save it so that you can go back and get a screenshot once you decide which thing. That you know how to type in different equations. And you can see visually and with some information which one you would choose and why for the best fitting for your data. Everybody feel like they can accomplish that goal? Okay, so you guys have the remainder of the period to work on your project. If you want to start right here, you would be working on part 4 of your project. It's perfectly okay to just go and start part 4, even if you haven't finished part 3. Or you can work on weekly review, okay? Or you can be working on the review assignment for the unit. So you guys have lots of choices for what to work on, okay?